Hello friends, welcome to this online refresher course that is Concerns in Educational Research and Assessment from National Resource Center for Education, Central University of South Bihar, Gaya. I am Kaushal Kishore from School of Education, Central University of South Bihar, Gaya. Today in this session we are going to discuss some FAQs which will also include some questions raised by some of the participants in this course. And these questions are related to hypothesis testing. Before going ahead or picking a question, first let us understand what is the idea, what is the process of hypothesis testing, how we proceed in educational research. And before taking a case of educational research, let us understand a concept, a logic, a rationale behind hypothesis testing by taking an example of simple court of law. What happens when someone is put in a court of law? Say, police charged a person and said that this person is guilty or this person is a thief. The person was presented in front of the judge. Now the judge says that I am going to frame a different hypothesis. There is a hypothesis framed by police. Police is saying the person is guilty. Let me write here, person is guilty. This is a research hypothesis. As you remember the characteristic of research hypothesis is an affirmative statement. So it is an affirmative statement. So it is a research hypothesis framed by police. Now to test this research hypothesis, as we do in educational research, judge is going to frame a null hypothesis, which is saying that person is not guilty. Now these two hypotheses, this is research hypothesis, this is null hypothesis. This research hypothesis is set as alternative hypothesis to this null hypothesis. I am indicating it as 0 now. Now I am saying it HA, alternative hypothesis. We means judge is going to test this hypothesis, the person is not guilty, and judge says to the police, okay, you bring evidences in support of your statement. And if you bring sufficient evidences, I will reject my hypothesis. And what is the judge's hypothesis? Judge's hypothesis is that person is not guilty. Judge is saying that you bring sufficient evidences and I will reject, on the basis of those evidences, I will reject my hypothesis and accept your hypothesis. I will reject the idea that person is not guilty and accept your hypothesis that person is guilty. But I need sufficient evidences. Suppose, say, judge says, okay, you bring 100 evidences. Then judge says, okay, leave, not 100. At least out of 100, you bring 95 evidences. And the police starts bringing evidences. 1 evidence, 2 evidence, 3 evidence, 4 evidence, 5 evidence, 6 evidences, 7, and so on. Suppose the police is able to bring 90 evidences. But the judge said that unless you bring 95 evidences out of 100, I am not going to reject my hypothesis that this person is not guilty. Police brought 90 evidences, but judge was asking for 95. So what will judge say here? Judge says that in lack of sufficient evidences brought by police, I am not able to reject my hypothesis. So the person is set free. You note one important thing here, that judge is not saying that person is innocent. Judge is saying that because sufficient evidences of being guilty are not presented, so I am setting him free. In the same way, now you take analogy of a case in educational research. In educational research, suppose you started a research. Is there any significant difference between achievement of boys and girls? It is your research question. You remember, you recall the process of research, you observed something different that is not usual, that is not in practice. It develops or it forces you to think about a research question. Like you observed that for years in state board, most of the toppers are girls. So there is a research question in your mind that whether girls are better in terms of achievement than boys, and hence your research starts. Then you frame a hypothesis, research hypothesis, which is an affirmative statement that there is a difference between achievement of boys and girls. And to test this hypothesis, you frame a null hypothesis that there is no significant difference between achievement of boys and girls. So I am writing these hypotheses here, that HA, there is a research hypothesis which will become ultimately alternative hypothesis, that boys and girls are different in terms of achievement. Okay. And what is your null hypothesis here? H0, that there is no difference between boys and girls. Now, same process will follow. You start bringing evidences for the difference. How will you reject your null hypothesis? Or I should say, how will you accept your research hypothesis? Your research hypothesis is an alternative of this null hypothesis. If you are able to reject this null hypothesis, you can accept this research hypothesis. So if you want to accept your research hypothesis, first you have to reject your null hypothesis. And for rejecting your null hypothesis, you need sufficient evidences of difference. Why I am saying sufficient evidences? Because you know that in behavioral sciences, there are chance factors. Since you have drawn a sample of boys or sample of girls, and you have conducted tests on these samples, but there are n number of error factors which we have already discussed in different sessions. Because of these error factors, we have to establish whether a significant or true difference exists between these boys and girls, and can we credit this difference in sample of boys and girls to the whole population of boys and girls? Can we generalize this beyond errors? For that we need sufficient evidences, and for sufficient evidences, say we said, okay, when we will get 95% evidences, if you are, I hope you are catching this, when I am saying 95% evidences, I am talking about 0.05 level. Or you said, if I get 99% evidences, 0.01 level. Okay, let us focus on 95% only. You said that if I get 95% evidences of difference, then only I will reject my hypothesis. So you start collecting evidences of difference. Your statistical test does so actually. You start collecting evidences for difference, and you collected difference, one evidence, two evidences, three evidences, four evidences, five, so on, so on. If you got 95 differences, you say at 95 difference, you say, okay, this null hypothesis is rejected. And since this null hypothesis is rejected, your alternative hypothesis is accepted. See, suppose you could not get 95% evidences, you could got only 90 evidences out of 100, 90% evidences. Since you decided that level of significance would be for 95 out of 100. So at 90% evidences, you are not going to reject your null hypothesis. So what will you say? Since I could not get sufficient evidences, I am not rejecting my null hypothesis, rather I am retaining my null hypothesis. Mind it, I am saying I am retaining my null hypothesis, I am not saying accepting my null hypothesis. Though literature point of view, these two things may sound similar. Retaining null hypothesis or not rejecting the null hypothesis or accepting the null hypothesis. With the point of language, according to the point of language, these two things may sound similar, but statistically these two things are different. When I am saying I am not rejecting my null hypothesis because I didn't get sufficient evidence, though I got 90 evidences out of 100 of difference, but I could not get sufficient evidences, that was 95%, to reject my null hypothesis. Now if I say that I am accepting my null hypothesis, what I am trying to say, that I am actually proving there is no difference between boys and girls. Now come to the chance factors again. If my hypothesis is to prove there is no difference between boys and girls, I again need 95% evidences for equivalence. Whereas I found that 90% evidences are of difference. If I have 90% evidences of difference and 10% are not there, it means 90% evidences are saying they are different. If I have to accept this null hypothesis, then I need 95% evidences of being equal. Those are already rejected. That idea has been already rejected here. That's why when we do not get sufficient evidences, or technically speaking, when our calculated value, say in t-test, is not up to the critical value, we say that since we didn't get sufficient evidences, we are not rejecting our null hypothesis, we are retaining it. In the same way, now you compare these two cases, judge is also saying that I am not saying the person is innocent, I am simply saying that in lack of sufficient evidences, the person is set free. And this is the language of judgment as well in the court of law. Accordingly, we also say that we are not rejecting our null hypothesis. So what does we do? When we test our null hypothesis, we collect evidences, or we get sufficient evidences, or I can say that we calculate the chance factors, and if we are confident up to a certain level, which are commonly 95% and 99% level in social sciences, in different sessions we will discuss that why these two levels are common, though there is not a hard and fast rule, but commonly accepted these two levels are there. It does not mean there are only two levels, these two levels. So if we had decided that okay, we will go for 95% confidence, then if we got 95% confidence and in saying that the difference is not due to chance factors, then we reject null hypothesis and accept our research or alternative hypothesis. If we do not get it, we do not reject null hypothesis, we retain it. So this was the related with this idea. Now one more question which have been asked about type 1 and type 2 error and how it is related with hypothesis testing, and how should we decide what level of significance we should choose, 0.05 or 0.01. Let's see that. In this part, we will try to search answer to the question how type 1 and type 2 errors are related with hypothesis testing, and how to decide which level of significance should we choose, 0.05 level or 0.01 level. As we discussed in another session, that there are not only two levels, that is 0.01 and 0.05. There may be a different level. There may be any level depending on the requirement of the research, need of the research. But in practice, these two levels are very common. How to choose which level should we go for? Before that, first let us understand what is the idea of type 1 and type 2 error. When we frame, here one thing we should notice, that hypotheses are always about population. But in inferential statistics, when we test our hypothesis, that is null hypothesis, we draw it, we calculate values for it, we calculate values for it from samples. That's why we use term significant. This idea we have already discussed in different sessions related to hypothesis. Now, coming to this idea, that in hypothesis testing, we frame null hypothesis, we keep our research hypothesis as an alternative hypothesis. While testing null hypothesis, there may be four situations. What? Suppose either we will reject our null hypothesis or we will retain it. And there may be two cases related to null hypothesis, whether my null hypothesis might be true, whether my null hypothesis is true or my null hypothesis is false. So this way there are four options regarding decision: if I reject null hypothesis or if I retain null hypothesis. Null hypothesis is true, null hypothesis is false. Suppose my null hypothesis is true, and if I reject it, then I am committing a mistake. Because if my null hypothesis is true, it must be retained. So if my null hypothesis is true and I am retaining it, it's the right decision. But if my null hypothesis is true and I am rejecting it, I am committing a mistake that we commonly known as type 1 error. In case if my null hypothesis is false and I reject it, then false null hypothesis must be rejected, so it's a correct decision. But if in my case null hypothesis is false and even then I retain it, then I am committing a mistake. Because null hypothesis, if it is false, it must be rejected. But if I didn't reject it, I retained it, then I committed a mistake, and that is called type 2 mistake or type 2 error. Not mistake, that's a type 2 error. So this is type 1 error, this is type 2 error. Type 1 error, when we reject our null hypothesis and null hypothesis was true, or precisely I should say, when we reject a true null hypothesis, it is type 1 error. When we retain our false null hypothesis, we are committing type 2 error. But how it is happening? But before that, first let us understand how do we reject or retain our null hypothesis. You quickly recall the process. Suppose you are conducting Z test. For Z test, you calculate critical ratio between differences of mean and standard error of difference. You remember the formula that this critical ratio was M1 difference M2 upon SED, standard error of difference. For this, you calculate and find a calculated value. And you compare this calculated value from a table value that we call tabulated value. For Z test, that is for large population, normal homogeneous population, the value for 0.01 level is 2.58, and for 0.05 level this value is 1.96. So if my calculated critical ratio value is 2.58 or more than 2.58, then we say null hypothesis is rejected. And in case of 0.05 level, if my calculated value is 1.96 or more than 1.96, we say null hypothesis is rejected. But from where these values are coming? These values are actually coming from normal probability curve. You remember normal probability curve? That is a symmetrical curve. You know all the characteristics of normal probability curve. Here one additional thing, the values which I have written here, they are for two-tailed test. And you remember the session from hypothesis that two-tailed tests are used when we frame non-directional hypothesis. My alternative hypothesis is non-directional, then I am going to use two-tailed test. For example, I framed there is a difference between boys and girls in terms of achievement. It's a non-directional hypothesis. But if I had framed that girls are better than boys in terms of achievement, then it is a directional hypothesis. And we have already discussed this thing, when we should frame directional hypothesis, when we should frame non-directional hypothesis. And in coming session we will also discuss how it will affect and lead to type 1 or type 2 error. Come back to this situation. These values are for two-tailed situation. In normal probability curve, this is the mean, median, mode, all are at single place. If I am talking about 0.01 level, it means I am saying 99% level. And if we take 99% area under this curve, this 99% say it will fall here in this area. This is my 99% area. In this situation, we call this 99% area as acceptance region, and these points beyond this area, this I am writing R, is called rejection area. So if my calculated value falls beyond this point, I will reject the null hypothesis, this side or that side. But if my calculated value of critical ratio falls between mean and this point, I will not reject my null hypothesis, rather I will retain the null hypothesis. Now if from normal probability curve you can see that this area from mean to this point, since the total area this is 99%, so area from mean to this point would be 99 divided by 2, and that is 49.50%. This is 49.50%. If you look at normal probability curve table, you will look for value 4950 and you will find that Z value here would be 2.58. Actually it will be between 2.57 and 2.58. Then we shift to 2 points after decimal, it will become 2.58. This value is 2.58. That's why at 0.01 level, that is actually 99% level, the value of this critical ratio is 2.58. So my calculated critical ratio, if it is up to 2.58, then I will not reject the null hypothesis. But if it is 2.58 or more than 2.58, then I will reject the null hypothesis. 2.58 is a critical point. If my calculated value is 2.58, then also I will reject the null hypothesis. In the same way, now you calculate value for 95%, this 0.05 level. If I am testing a null hypothesis at 0.05 level or 95%, then instead of this 99%, my acceptance area would be 95%. And say this is between this and this is 95% area, and this would be half of 95, that would be 47.5. And if you notice if you look at normal probability curve table, you will find that the value for 47.50%, here the Z value is 1.96. That's why this value here is 1.96. You notice one thing here, that in this situation the area is in between of the normal probability curve, and for rejection both the tails are open. Both the tails of normal probability curve are open. That's why, since two tails are open, we call it two-tail test. But it means the difference, for difference both options are open. If I am saying there is a difference between boys and girls, and I rejected my null hypothesis that there is no significant difference between boys and girls, this was the null hypothesis and I rejected it, then my alternative hypothesis says there is difference between boys and girls, so the difference is open for both the ends. It means either boys may be at high side or girls may be at high side. But what happens when we frame directional hypothesis? Then we use one-tail testing. Let's see how we do it. Since we are picking a single direction, and what happens there? Suppose this is my normal probability curve again. In this normal probability curve, this is mean. Now I want to test my hypothesis at my null hypothesis at 0.01 level. 99% will be the acceptance region and 1% will be the rejection region. But since it's a one-tail test, suppose I am saying that girls are better than boys. In this case, since it's a single direction, the total 99% area of acceptance would be at one tail, and the total rejection area of 1% would be at one tail. Say I am taking this tail, so here in this case, this would be the 99% area, and this would be the 1% area, and this is the rejection area here, this one corner. What difference is there? When we were using two-tail testing, then this 1% area was divided on two tails. So this area was remaining 0.5%, here it was 0.5%, and this was 49.5%. But now, since it's a directional hypothesis, we are using one-tail test, the whole 1% rejection area is situated at single side. And then how much area will remain here? This area from mean to this point would be 49%. Since this is 99% and this area below mean to infinite is 50%, so this area is 49%. And if you notice from normal probability curve table, you will find that Z value here for 49%, that is 4900, is 2.33. Now the value has changed. It means for one-tail testing at 0.01 level, if my critical ratio value, which I have calculated, is 2.33 or more than 2.33, the null hypothesis would be rejected. Whereas in case of two-tail testing, the minimum required value of critical ratio was 2.58. It means null hypothesis at the same level. Earlier was also 0.01 level, now it's also 0.01 level, but for two-tail testing, the minimum required critical value was 2.58. For one-tail testing, the minimum value required is 2.33, which is less than 2.58. And if my calculated value reaches to this value, then we reject null hypothesis. It means for the same level, that is 0.01 level of significance, in case of directional hypothesis, that is one-tailed testing, the null hypothesis is rejected sooner than in case of two-tailed test. And this will consequence to type 1 and type 2 error. If you recall type 1 and type 2 error, okay, let us understand with this diagram what I am trying to say. Suppose this is my normal probability curve, and in this curve, this is my mean, and this is 2.33 value, and this is 2.58. It means for 99% or 0.01 level of significance, for two-tailed testing, the rejection area will start after this. Whereas for one-tailed testing, in the same situation, for 0.01 level, rejection area starts from this place. When we start moving from this place, not rejected, not rejected, not rejected, not rejected, when we reach to this place, hypothesis is rejected, null hypothesis is rejected. In case of one-tailed testing, I reject my null hypothesis here. Whereas in case of two-tailed testing, I have to move till this place, from here to here. So I will reject my null hypothesis later. What is happening? You remember type 1 error. When my null hypothesis is true and I reject it, I am committing type 1 error. Take an example of a value, say 2.40. My calculated ratio is 2.40. But if I was testing a two-tailed test, for this value, the null hypothesis was retained, not rejected, because this is less than 2.58. But it means my null hypothesis is true. Since I retained it, why I retained it? Because it's true. That's why I retained it. But what happened in case of same hypothesis, same situations, everything is same, but I framed my research hypothesis in directional form. And now I am using one-tailed testing. Same calculated value, but when I use one-tailed testing, after reaching at 2.33 level, I will reject it. For the same calculated value, for the same level of significance, my null hypothesis was rejected for directional test, whereas it was retained, not rejected for non-directional test. My null hypothesis was rejected for one-tailed test, whereas my null hypothesis was retained, not rejected for two-tailed test. Out of these two situations, one thing will be true only. So if my null hypothesis is true and I had to use two-tailed testing, then my null hypothesis was not rejected and it was a right decision, because null hypothesis was not true in that case. So now, if mistakenly I had framed directional hypothesis in place of non-directional hypothesis, actually non-directional hypothesis was required, but mistakenly I framed directional hypothesis. So while testing, if I get such value like 2.40, I will commit type 1 error, because I will reject my null hypothesis, whereas for two-tailed testing it was to be retained, and this way I commit type 1 error. If we frame directional hypothesis in place of non-directional hypothesis, and my literature is indicating for non-directional hypothesis, even then I frame directional hypothesis, I am committing type 1 error. One more thing, what happens to when we change our level? We had just discussed that in our normal probability curve, say I am talking about two-tailed testing only now. I have framed non-directional hypothesis and I am using two-tailed testing. Then for 0.01 level, the value here is 2.58. So my rejection area is after 2.58. Value for 0.05 is 1.96. That 1.96 is here. So my rejection area is after 1.96 in case of 0.05 level. Suppose I decided to test my null hypothesis at 0.01 level, but it is not rejected. Suppose my value is again say 2.40. In this case, for two-tailed testing at 0.01 level, it will not reject it because minimum value required is 2.58. Then what did I do? I changed my level of significance and shifted it to 0.05 level. In that case, when I shifted to 0.05 level, now the same null hypothesis for the same situations, for the same data, it will be rejected because for 0.05 level, the required value is 1.96. Now, it means by reducing the level of significance from 0.01 to 0.05, I am forcibly rejecting my null hypothesis. If I had used 0.01 level, my null hypothesis was not rejected. Whereas by using 0.05 level, now I have rejected my null hypothesis. I have rejected a null hypothesis which was true. For 0.01 level, I am committing type 1 error. But interestingly, suppose I decided for 0.05 level, null hypothesis is rejected, then I raised my level to 2.58, that is 0.01 level. For the same value, my null hypothesis is not rejected now. So I am at 0.05, my null hypothesis was false and I rejected it. But at 0.01 level, it is not rejected, it is retained. I am retaining a false hypothesis, I am committing type 2 error. When my level of significance is lower down by from 0.01 to 0.05, I am committing type 1 error. Whereas when I am lifting it up from 0.05 to 0.01, I am committing type 2 error. Interestingly, type 1 and type 2 errors are inversely proportional to each other. If one is reduced, second is increased. If second is reduced, the first one is increased. That's why we have to decide a level of significance depending upon our consequences of the research. How to decide it? What will be the consequences of rejecting my null hypothesis or retaining my null hypothesis? It depends on that. If in my research type 1 error is more dangerous, then I should go to maintain type 2 error, and we can maintain type 2 error by keeping our level high. Then how to decide which level should we go for? We should decide that because of what error, because of which error, results will be what in my research. Precisely, what will be the consequences of tolerating a particular error, whether type 1 or type 2. If in my research type 1 is not so severe, type 2 is severe, then obviously I should tolerate type 1 and go for lower level. But if in my research type 1 is serious, type 2 is not so serious, then I should tolerate type 2, not type 1, and I should keep a high level. In general, it is said that type 1 error is more dangerous. But remember, it cannot be generalized. It is always contextual. It depends on your research, consequences in your research. With the help of this, you can also determine that if my null hypothesis is rejected at 2.58, that is 0.01 level, it will also be rejected at 0.05 level because 1.96, that rejection area starts before 2.58. That's why we say that if my null hypothesis is rejected at 0.01 level, it will definitely be rejected at 0.05 level. Whereas when we say that my null hypothesis is rejected at 0.05 level, will it be rejected at 0.01 level? We cannot be sure until unless we test it. Now another case, if my null hypothesis is retained at 0.01 level, will it be retained at 0.05 level? Again, not sure. Suppose the value of 2, the null hypothesis will be retained at 0.01 level, but will be rejected at 0.05 level. But if my null hypothesis is retained at 0.05 level, it means the calculated ratio is less than 1.96, it will also be retained at 2.58, that is 0.01 level. One more interesting thing, not only because of this setting level 0.01 and 0.05, but also because of sampling error. These errors take place, type 1 and type 2. My research question is there any significant difference between average height of Indian males and American males? Normally, if I consider there is no difference, so if there is no difference, my null hypothesis will be retained. But from India, if I collected data from a place, some say hilly area where average height of males is less comparatively to other regions, then my sample is coming from that region, and when I will compare, definitely in this case the difference will be found significant and null hypothesis will be rejected. In this case, by not collecting a representative sample, I rejected my null hypothesis, though it was true, because actually there is no difference between American male's height and Indian male's height. But because of wrong sampling, non-representative sampling, biased sample, I rejected my null hypothesis. I rejected a null hypothesis which is actually true. I have committed type 1 error. By this way also we commit type 1 and type 2 error. So friends, this was session again related with hypothesis testing. We will meet in another FAQ session. Thank you for watching this video. Namaskar.